All right, class. In this lesson, we're going to talk about the domain of a function and being able to find the domain. And because of the complicated nature for this is going to be a two-parter. So first off, we'll start with a definition of a function. A function is a relation. If you don't know what a relation is, a relation is a pairing between two sets. So you have a set A and a set B, and you say things in A go with things in B. All right? So it's a pairing in which every element x in the domain set has a unique y in the range set such that y equals f of x. Okay, so the key thing here, we want to expand upon what really is a domain. So for the functions that we're going to deal with, we're going to assume the domain is a subset of the real numbers. You certainly could have functions that don't involve real numbers, that involves maybe complex numbers or other things. But for calculus, we're going to assume for everything, there's no I in calculus, so we're going to assume everything involves real numbers. Okay? So the domain is the set of, I'm going to say it this way, legal x values for which the function is defined. Okay, so what's not legal? We'll get to that in a second, but basically we need things to be defined for real numbers. Okay, so what is not legal? Well, there's really three bad things in math. And when I say in math, I mean for real numbers. Okay, so you can pause it right here, and you can maybe make a list of what you think the three things would be, and then I'll start in a second, and I'll give you the list. So hit pause and make your guesses. Okay, so the three bad things in math for real numbers, I bet this is on your list. I bet this is the first thing on your list, is division by zero. We'll learn more about division by zero when we get to calculus, but that usually is considered bad. Okay, second thing, we'll see if this is on your list. You might have mentioned square roots. Okay, it's not just square roots, it's any even root. So even roots of negative numbers. Now notice, we're saying even roots. So what about odd roots? So can you take the cube root of negative 1? Absolutely, it's negative 1. So odd roots don't have this problem. Only even roots do. And then the last thing, something you probably learned more about last year, logarithms. Of non-positive numbers. Oops. Okay, when we say what does non-positive mean, it means negative or zero. So log of a negative number is actually like the square root of a negative number. It's a complex number. And the log of zero is kind of like division by zero. It's bad. Okay, let's just do a couple of examples where we're finding the domain. Okay, so we'll take f of x here. We'll let it be x squared minus 2x plus 1. Okay, I'm going to pause for a second here and let you maybe work this out, and then you can come back to it and see what if your answer jives with mine. Okay, so if you hit pause then and did your work, what kind of bad math do we see here? Do we see division by zero? Well, there's no fractions. Do we see even roots? No, I see a square, but not an even root. And certainly I don't see a natural log or any other kind of log. So there's no bad math here. So the domain of f is all real numbers. Okay. Let me just say, as far as notation goes, you can write it like this. This is called Blackboard script. You can say from negative infinity to infinity. That would be interval notation. Or you can literally just say all reals. I would count all three of those for full credit. Okay, let's call that example 1. Let's do another example. Okay, f of x equals the cube root of x minus 5. So hit pause here, and I'll give a brief pause, and then we can come back and discuss it. Okay, so once again, even roots are the ones that are bad. This is an odd root. This is a cube root. I don't have a problem with that. So what's the domain going to be? You guessed it, all real numbers. And I'll use the interval notation. You don't have to, so I said all three of these are fine. Just pick one of them. You don't have to say all three. Okay, last one for this lesson, and then all the other ones going to be on a separate lesson. So f of x equals x minus 2 over x squared plus 5x plus 6. Okay, so what's the deal here? What's the deal for this example? We have a fraction, so that means looking at my list up here, we possibly have division by 0. So what values make this thing divide by 0? So typically, here's what here's the way of looking at it. All right. So I need to know what makes the bottom equal to 0, and I'm going to say not those. Okay. So I'm going to set x squared plus 5x plus 6 equal to 0. You can say not equal to 0, but that actually causes another problem. Okay, that's actually two different inequalities. X squared plus 5x plus 6 would have to be bigger than 0, and x squared plus 5x plus 6 would have to be less than 0. So don't say equal, not equal to 0 here. You actually want to know where it's equal to 0, and then you're going to say not those things. Okay, so this is something that's easily factored. Factors of 6 that add up to 5, that would be 2 and 3. So it factors into x plus 2 times x plus 3. And then we know that my two answers would be -2 and -3. Okay? So that's what causes division by 0. So when I write the domain down, you need to say x is not equal to -2 or -3. And you can say it like that. I want to show you interval notation here, and let's talk about it just briefly. So you could say that we go from -∞ to -3. You want to attach things on the other side of -3, so you use the union symbol. It's not a U, it's a union symbol. And you would say from -3 then to -2. And then you would also add the things that are bigger than 2. So you would say from 2 to infinity. Okay, so which one of these is easier to read? This one. So we don't always want to give interval notation if it's messy. Okay, it's much easier to see not 2 and not 3 than all this mess. And imagine, what if there were 5 numbers? What if there were 5 numbers that x couldn't be? That would be a giant set of inequalities. It would be really difficult to read, and saying not whatever 5 numbers it is much clearer to the reader. Okay, that's it for this one.